Hello, good evening, everyone. So we'll start off with today's session. Today's an extra session which we wanted to have because of the one session that we missed out on Saturday. So this will in general be looking at the fifth lecture on monitors, because we have looked at all the other four lectures in the last week. We'll also look at the activity question, practice questions if you have any questions. So first, do you have any questions on the earlier some content, or you have anything you want to ask, or shall I just go ahead with the lecture? Okay. Okay, so I'll just go ahead with the lecture 5, which is on monitors. So just for people, am I audible enough or?
Yes, ma'am. Yeah.
Okay. Yeah, thanks. So just for people who were not in the loop, a quick recap of what we looked at last week. So mostly it was on like threads, the purpose of threads and how threads are implemented in Java. So threads are nothing but we refer to them as something like lightweight processes. So process is nothing but a program which is in execution, which is in the main memory, which is being executed. And within a process, when you want to have certain things happening concurrently, say for instance, your code is actually taking some data from the database, and in the same time you want to process a list of items, and the result of both you have to use for some other process, right? So access the database and the process list can be done concurrently within the same process, right? So both of these you execute as in concurrently is what are known as threads. So last week, we also looked at how the processes are different from threads, in the sense that each thread has individual stack of activation records, whereas the memory, the location memory where the variables are allocated are common for all the threads which are initiated by the same process. So we looked at those things, that memory image of that, the snapshot of those threads in the image will give you a better idea about how these threads are executed concurrently, why certain variables are shared and everything. So eventually then we looked at, okay, because the heap is shared, the memory, there are shared variables between the threads, right? So then there arises the problem with inconsistency of data, because the same set of variables can be accessed and updated by number of threads concurrently. So there arises the problem of ensuring the consistency of data. Threads are required because it helps you to do a certain thing while something else is happening. So for instance, as in the same example which I just mentioned about, you're waiting for some input from the database, which is somewhere far away in the internet. Same time, you can do some list process so that by the time the data reaches you from there, you can finish off this processing. At the same time, the cons or the disadvantage or the difficulty involved in using the threads is that both or multiple threads will have access to the same set of variables, possibly resulting in inconsistency of data. So for this, we also looked at like how this can be circumvented. And we also looked at the terms called race conditions. So a race condition is something where if you have say two threads and each of them has say three statements. So statement one, thread one, followed by statement from thread two, then the second statement from thread two, then the second statement from thread one. So these can get executed in an interleaved manner. I'll just share screen while I'm speaking, so probably make more better sense. So you have say thread one, this thread two. So you have say statement one, statement two, statement three, and statement four. So these can get executed in any order, right? Any order that they want. So that can possibly result in a lot of confusion in the data. So this is the order I'm just showing some. This can execute in any order, and because of this, the ensuring the consistency becomes difficult. So wherever there are variables which are being accessed by both these threads, resulting in an inconsistent state. Say, for instance, you have a counter which thread 1 is incrementing and thread 2 is decrementing, and they are trying to print. So thread 1 is expecting an incremented counter to be printed, whereas thread 2 is expecting a decremented counter to be printed. And finally, whatever is that final value of the counter depends on the order of execution in which these statements were interleaved. So this can result in what is known as a race condition. Race condition is this kind of the outcome of these statements of execution depending on the sequence in which it was scheduled. So the programmer does not have much control on the sequence of execution. This is actually the order in which the statements are scheduled. That is a decision that is taken by the JVM and the operating system in turn. So this race condition is leads to inconsistency of data, or we cannot predict the output of a certain sequence of execution. So for that, so the particular part of code, right, particular lines of code which are actually accessing a shared variable, say this is C equal to C plus 1. There is another one which is using C equal to C minus 1. And this is using a print C, and this is using a print C. So these are all like accessing the same variable C, right? So this portion of the code which is accessing the shared variable and possibly resulting in a race condition is known as the critical section. So in order to ensure the consistency of data multiple threads are executing, we must ensure that we provide mutually exclusive access to threads to such shared variables. So that actually leads to what is known as mutual exclusion. Mutual exclusion means that only one thread should be given exclusive access to the variable C at one point. And only after the thread 1 finishes it, you give access to thread 2 to the shared variable C. So this is the mutual exclusion. So we have looked at terms like race condition, mutual exclusion, critical section, all these things. And we also looked at how to provide a mutual exclusion through some very basic programming constructs. So the first thing was we looked at something using this variable called turn, which can, so if there are two threads, say thread 1 and thread 2, we use this variable to say that whether it is the turn of thread 1 or the turn of thread 2. And so you can just go through the lectures and last week's live sessions to understand better. I'm just doing a recap so that people who have attended at least can follow up. Yeah. So whether it is a turn of thread 1 and thread 2, so it's something like they are allowing the other thread, one thread is allowing the other thread to take turn, and when it assures that, when it is assured that it is not its own, when it is not the other thread's turn, is when it takes control of that thread. And we saw that this can actually lead to what is known as starvation, possibly due to some exception being encountered at some of these steps. Then we came up with another solution in which we used two variables, request 1 and request 2. Each of these being separately handled by thread 1 and thread 2, in which they will request 1 will be set to true if thread 1 wants to enter the critical section. Request 2 will be set to true if thread 2 wants to access the critical section. So this avoided the situation. This did not have the disadvantage of being starved of getting access to the critical section, but it actually leads to what is known as a deadlock. So there was a clever implementation of using both these variables to, all the three variables, request 1, request 2, and turn 2. So these two are Boolean variables, and this is a variable that takes just value 1 and 2. So Peterson's algorithm is a clever combination of using these two algorithms and uses all the three variables to ensure that there is no starvation and there is no deadlock also. Then we saw that, okay, now this is for 2 threads. How do you generalize it to more than 2 threads? Suppose you have n threads, what do you do? Then we looked at what is known as Lamport's bakery algorithm, in which we saw that there are mechanisms in which, we saw that there are mechanisms in which n threads can be given turns to access the critical sections of data. So eventually at the end of everything, we saw that unless the programming language, the underlying operating system gives you a construct or a technique by which you can ensure that this kind of concurrent access can be enabled at a system level. That is that whatever we are trying to do here is we are actually using Boolean variables to check whether, okay, whether if this is true, then something happens. If this is true, then something else happens, right? So this is something like the programmer is actually using these variables and these techniques to ensure mutual exclusion. But we observe that at some point, these are all what we know as a test and set. Test and set is actually nothing but you test for them, whether you test if a certain thing has certain value. This is the test step. And if this is the case, then you set a certain value. So this is so as I was saying, like you check whether if the turn value is something, you do something. If request value is something, you do something. But the problem is even this step, right? This step can be subject to some concurrent access. Say one thread is checking this at the same time, the other thread is checking this, and both of them are setting this variable at the same time, then it can again lead to loss of data, inconsistency of data. So we saw that this kind of an operation, which is test and set, has to be something known as atomic. Atomic in the sense, this full set has to be executed as if it is a single operation. Not like if is executed first, like if condition is checked first and then set is set first and next. So it means that if a thread is going to execute the if statement, then immediately it will execute the set statement also. So test and set has to be treated as an atomic operation. And for this, the programming language has to give us constructs which will support this kind of an atomic test and set. And we saw that there are something called as semaphores. Even Java also has a semaphore class, but we are not looking at these lectures. In fact, semaphores, people with computer science background know that it is mainly built in the operating system course. So semaphores is some, very binary level or system level, very low level construct, something like you call it as P of S and V of S. So these things, please go and check in the lectures again. I'm not going to it. P of S. So P of S and V of S are constructs used by the semaphores, which will ensure some low level mutual exclusion at the system level. Problem is, this is highly prone to programming errors. So finally, we have something called as monitors, and that's what we are going to look at today. Okay, so even monitors also, I'm just going to explain it in general because that is all what is there in the week 10. How Java implements monitors is something that we will start looking tomorrow. We'll look at tomorrow when we start off with the monitors in Java topic in week 11. So what does monitors do? Monitors is actually, okay. So instead of just going to monitors in Java, let me just put it this way. Monitors are in general treated as, classes and objects. Object-oriented ways are only in which monitors are looked at. Okay. So if you recall what an abstract data type is, right? So abstract data type has a set of data which is operated upon by a set of methods, right? Now this is an abstraction. So this is this encapsulation abstraction, or whatever you call it. Your data is actually protected by ensuring that a certain set of methods only have access to this data. Now what does the monitors ensure? The monitors ensure that even these methods which have access to data have a controlled access to the data. See, for instance, if there are two methods, say method 1 and method 2, both of which have access to this data, then we say that, okay, the access to the data, here it is actually handling the data inside the method, right? So what we do is that if both of them are capable of editing this data, then we give a controlled access, or rather the method 1 or method 2 can be executed only in a synchronized manner. So the big keyword used in Java is in synchronized and not monitors. But in Sir's lectures, he demonstrated using something called as the pseudocode, right? So there he say that, okay, every class that you have, right? Every class, the class test, you can look at it as something like something that has the functionality of a monitor, which will give controlled access to the data by the methods that are capable of editing this data. So In the case of threads, these are more relevant in the case of threads, right? Threads where multiple, simultaneous access to the data is possible. So every class, you can look at it as something like the monitor. And inside wherever methods are there, these methods will be given controlled access to the data. So if one method is actually handling the data, the other method will not be given access to the data. So that is how you kind of locking or synchronization, whatever. These are the terminologies that will come in the next week. We're just giving you an idea. So how does Java does this? How does Java do this? Okay. So let us see. So suppose there is a critical section, code which is critical section here, and you have multiple threads which want to say thread T1 and thread T2 and all these methods want to, so this T1 wants to gain access to this critical section, T2 wants to gain access to the critical section. So generally what happens is all these threads are there in the stack, right? This thread 1 is there in the stack, thread 2 is there in the stack. But just to access the critical section, you provide a queue. This is the external queue to this critical section. We call it as an external queue, which is something which is outside the class. Okay. So we give this outside the critical section, rather the object of the class. Okay. Now we give this critical section, I mean, a queue access. So if thread 1 wants to access, thread 1 will be there in the queue and thread 2 will be there. Now once there is no other thread which is executing this critical section, then we give, then thread T1 is given access to this critical section. And then, sorry. So thread 1 is given access to the section where it has to. So I'll just give that example that sir was explaining. So here you have a class bank account. And there you have, say, number of accounts. So this is all like a pseudocode. So there could be, I mean, this could be some, I mean, I'm not sure, some data type. And then there is a method which will transfer amount from one account to another, one account source to the account destination. Then there is another method which does the audit. Audit is nothing but it sums up all the balance in accounts, all the accounts, all 10 accounts. This is what I want. Now, if you have seen the thread lectures, you would remember what sir was trying to say. So suppose you have, say, accounts, say account 1, account 2, account 3, account 4. I'm just going to do for account 4. You want to transfer, say, 100 rupees from account 2 to account 3. Okay. So you want to transfer from account 1, where I put the amount. So transfer, which is a source, is account 2, and from here you transfer to account 3, and you transfer, say, amount 100. Okay. So, say, suppose the balance of account 2 is, say, 200, and this account was, say, 50. Now you want to do the transfer. At the same time, there is an audit method which is there. Audit method also, if it is running concurrently along with the transfer method, then it will try, what does the audit method do? It is actually finding the sum of the amounts of the balance in all the accounts. Now, every time you do an audit, you should get the same sum, irrespective of whether account 2 has 200 and account 3 is 50, or after transferring 100 rupees from here, you have account 2 which is 100 and account 3 which is 150, right? So when the audit is taking the sum of all these accounts, so suppose this has, say, 300, this has, say, 500. Now what should be the total sum all the time? It should be 500 plus 300, 800, 200, which is 1050. 1050 should be the total of all the balance of all the accounts taken together here, right? But when you're doing the transfer from account 2 to account 3, a rupees of 100, what happens is, say, account 2 is assigned the balance in account 2 minus account 3 is assigned account 3 plus 100. So what if the audit takes the sum at this point, right? The audit is actually taking the sum of values, and before the account 3 is getting executed, if you do this, then you will find that the total is less by 100 because the account 3 still has 50 only, whereas account 2 has been reduced by 100. Now account 2 has only 100. So instead of 200, this will only have 100. Instead of here, instead of 2, account 2 having 200, it will have only 100, whereas account 3 will have 50 only. So if you take the total, eventually this will have minus 100 than what is expected, right? So this is the inconsistency that we were talking about. Now, how does the okay? So the audit function. Now, what if we ensure what if we insist that this transfer method and the audit method, these both have to be, or rather the class bank account in itself is something like a monitor. This means that it has to ensure that all the methods that are accessing these accounts will be doing it in such a way that this kind of an inconsistency doesn't happen. So for that, what it will do is, if there is a thread which is actually running the transfer, it will actually make that transfer wait here, like transfer is waiting here if the audit is going on. If again the audit is happening, then it will wait for the audit transfer function to completely get over, and then the audit is let in. Now suppose there are other difficult situations. Say for instance, there are a sequence of withdrawals and transfer which are taking place, and say account 1 has to transfer. So suppose the transfer amount is 250. Then we know that account 2 does not have 250. But at the same time, this was initiated because there was another transfer which was supposed to happen from account 1 to account 2, which is say 100 rupees. So what happens if account 1 to account 2 is given 100? So from here 300, this will go to here. So this from 300, this would have gone to 200, and account 1 will now have 200. Account 2 will have 300. Account 3 will have 50, and account 4 will have 500. Right? So this is so first this transfer should have happened, and then this transfer should have happened. Then we can very well transfer 250 from here to here, right? But if this was the situation, like this was the initial situation, and we were trying to transfer the 250 while this account had only 200, then we cannot do this transfer. So apart from the external queue which is happening here, right? This is known as external queue. We can also have an internal queue inside this. It says that okay, I will currently this transfer does not allow the transfer does not allow this because there is insufficient balance. So this transfer will actually go and wait and let this transfer happen. So these are all hypothetical situations where I'm trying to tell you the importance of what there are two types of queues which are possible. See, one is the method in itself, right? Whereas the other one is within the transfer method, if you are waiting for, it is not like this transfer is over. It is the transfer is not leaving the control because the transfer has happened successfully, but instead it is waiting so that some other transfer can take place and then this transfer can happen. So there is also possibility of an internal queue which can be there. But that's it. Java has only one queue. So we don't have to worry too much about this internal queue. So I'm also explaining about this, and that's why I thought I'll just mention a scenario where this will be possible. So that is it. Okay, so how does Java? Just one second. So does anyone have any questions to ask? So, anything related to threads or synchronization or critical section or whatever, anything related to these? Okay, fine. So that's about the monitor. So this Okay. So how it is done in Java, right? So what it does is, see, suppose you have a class set test. So in Java, say you have method 1, and there is this method 2. Now suppose you want to ensure that method 1 and method 2 have to be synchronized in a way that it accesses the data here. What we do is we simply add a keyword synchronized here. The keyword synchronized is the easiest way of ensuring that the method 1 and method 2 are synchronized, such that once a thread gets access to the synchronized method whichever it is there, no other thread can get access to this synchronized method or the other synchronized method inside this class. So if you say this method is synchronized, and only this method can happen. And once this synchronized method is entered, you give there is some method called wait method, another method called notify method, notify. So when one thread is actually waiting for something to happen, like other thread to relinquish the control, whatever, the wait method is evoked. So in the wait method is not specific to a thread. The wait method is actually inside the object class. So wait method can be invoked from inside any class. From within every class, the wait method can be invoked on itself because it is there from the object class. So if you invoke the wait method, then it is actually waiting for the other thread to relinquish its control. Now, once the thread finishes execution of this synchronized method, it will use the notify method or the notify all method to signal other methods that, okay, one of you can actually get ready and start, it's not start, you can actually claim your access to the synchronized method. Okay, so that is what is meant by the notify method. So what Java does is, if you just call the notify method randomly, one of the waiting methods, without any priority, it's actually internally decided by the system. One of the methods is woken up, and that is actually given access. If you give the notify all these methods are given access, but only one of them is scheduled. So this is still not like very clear as to what is the real purpose of the notify and notify, the differentiation between, because eventually, even if you notify all, it's only one method that will get access to a synchronized method. By notify method again, this thread cannot specifically say, okay, there's one particular thread has to be notified. This is again saying some other thread has to be notified. That is it. Again, when you do notify all, it will invoke, it will wake up all the threads which are in the waiting state, and one of them will get access to this synchronized method. So that is the whole theory of the monitors. How they synchronize method. There is also something known as a synchronized block. So two ways in which Java achieves the synchronization is synchronized method and synchronized block. So synchronized block actually gives access to a particular object. You say that, okay, this object. So when you say synchronized method, it is for this whole class, right? Every object of this class has to have the synchronization with respect to this method. But when you specify synchronized block, it's only for a specific object. So inside the synchronized, you give the object as the parameter. So this is possibly inside a method, say void display. This is happening. So much code is there, and in the middle of this, you have the synchronized code coming up, which is like this. Whatever is there inside has to be. So that's about the theory on monitors, and the coding part of it we'll do in the next week, or starting. Okay. So, does anyone have any questions on the activity questions or practice questions? Okay, I'll go to the questions one after the other. Okay. Can you see this question? Nalini, can you see this lecture? Yes, sir.
Yeah, yes, ma'am. Yeah, it's visible. Your screen is visible, ma'am.
Okay. So I'm not sure. So generally weekends, I find that people are less responsive because I'm assuming either you are some office or somewhere where you cannot respond. So I'm just assuming. So if there is anyone who can attempt these questions and answer, let me know. Otherwise, I'll just go ahead and explain the answers. Does anyone want to give it an attempt? Fair enough. I'll just go ahead and explain the answers. So, okay. So we start off from the main method, right? Main method is there. Then you are instantiating this class, which is example, which extends thread. So this is a thread. You are actually created an object of this thread. You are invoking the e.run method, which is a run method inside this, and you are printing numbers from 3 to 5 here. You are printing number 1 and 2 here. So then what is the sequence of printing is what is asked. So generally the catch here is if you are invoking the e.run method, right? If you're invoking the e.run method, it is just like any other method in Java. This does not achieve the multi-threading at all. So if you invoke e.run, it will just be executed sequentially. So for instance, immediately after E, you have e.run. So it will go here, it will print the 1 and 2, and then it will come to the next statement, which is here, which is 3, 4, and 5. So what happens if you do the, what happens if you want to do the multi-threading is we have seen, we have to use the e.start and e.run. If you do it as an e.run, then what happens, the activation record is you have the main method here and then you have the run method here, that's it. But if you do it as an e.start, you have a separate activation stack for main and another activation record stack for the run method. This is how the e.start and e.run behave differently. So if you want to have multi-threading happening, then you have to invoke it using e.start. Otherwise, this will just get sequentially executed. The run method will be executed first, and then next function is for loop, by which you will get the output as 1, 2, 3, 4, and 5. Here the output is clearly predictable because there is no multi-threading happening. So just recall that main is also executed as a thread in Java. Okay. So whereas there is, even when there is a thread running, main is also executed as a thread. So main will also compete for a CPU instruction time. So for one statement from here, one from here, one from here, one from here, one from here. So whichever order this permits, if you are expecting that kind of multi-threading, you should use e.start, which is the crux of the next question. So if you see here, instead of e.run, you have e.start. And here, the interesting thing is here again you are printing 1, 2. Here you are printing 3, 4, 5. Right? So the interesting thing is even though 1 and 2, say 1, 2, 3, 4, 5, there can be some interleaving which happens like this. And 3 can get printed somewhere here or whichever. The interleaving between this and this does not happen. So this is something we have to observe. There is a sequential execution between 1 and 2 that happens, and a sequential execution between 3, 4, and 5. 4 will be printed only after 3, 5 will be printed only after 3 and 4. Of course, there are exceptions, but you can forget it for now. Assume you can just take it for granted that the sequential execution is what is happening in each method. Whereas the interleaving happens between this set and this set, not within the sets. It's across these two sets that the interleaving happens. So whatever are possible sequences there, 1, 2, 3, 8, 4, and 5 can come in a single set. So I'll just show you the answer that we give you. So this is possible because 1, 2, and 3 and 4. This is possible because 3, 4, 5, and then you have 1 and 2. This is also possible because 3, 4, 5, 1 and 2 are getting 0. So all of them are possible outputs of this. So sequential execution within the same thread, across the threads, you can have interlinked execution. So if you simply invoke the e.run, you just invoke it as a method, e.start, you invoke it as separate threads. Now you have this question, you just reduce the size. Is it visible? No. Only is it visible?
Yeah, yes.
Yeah, yes, ma'am. It's visible.
So here we start again at the main code. So here you have this method system dot current time in milliseconds, right? So here, so there is one issue with this. Maybe you will also find it when you're trying to run it. But here, this is a large integer. So if you want to have an exact value, then you should use a long. So integer is actually okay for. I mean, just to understand the concept of threads, you don't have to worry too much about it. You can still use the name. But yeah, current time in milliseconds. So this is again. I think it is a current time of milliseconds starting from Jan 1, 1970 or something. Okay. So today is 11th July 2022, right? So how many milliseconds have passed starting from Jan 1, 1970? That time, right? From that onwards until how many milliseconds? That is this method, current time in milliseconds. So you are instantiating. Okay, so you have an example class here, which is again implementing runnable. So you can have a thread object created with this, with an object of the example as a parameter. And the constructor actually takes an integer, which is a start, and then you have a run method that will come to that. So now you are actually instantiating the example. I'll just erase the things. This is just for your information. So here, yeah, example, you have created an example object and you have created a thread with that example object. You starting instantiating this. Now inside the run method, what do you see from 0, 1, 2, 3 or so 0, 1 and 2, you execute this. So this is sleeping for 1000 milliseconds, which is equal to 1 second. So you can, for now, this is just a regular logging function that is put here. This does not have much significance with respect to the thread here. Now the end is, again, after the example start, t dot start, it comes here and now it checks what is the current time in milliseconds. So every time you check, it would have increased, right? So this is the current time in milliseconds. So the difference between these two statements, right? This statement and this statement will give you the time that has elapsed between the execution of whatever steps have come intermediate, right? So that is the difference that you're calculating and you're actually converting it into seconds by dividing it by 1,000. So in seconds, now you're getting it. So you're asking, I mean, you're being asked how many seconds. So for now, we are actually given it as 3 seconds, but it could vary. For now, I think the two options that we have given it as 3 seconds, but it could vary depending on your machine. So the question is, again, which of the following options are possible is the question, and once again, I'll show you the options. For that, okay. So basically the question is, does it generate a compiler error? There is no reason for it to generate a compiler. I'll tell you case where there is possibly a reason for a compiler error, but not in this example. I complete later. There is no example. It does not cause any deadlock. There is no reason for a deadlock because no two functions are calling each other, right? So there is no deadlock here. And in this one, this order in which the main thread and child thread are getting printed. So here in this statement, you have the main thread which is printing the main thread, and here you have the child thread getting printed. So the sequence in which these two get printed, right? This will be totally unpredictable. That is the main idea in this. So you have different order in which the first one you can print the main thread or first one you can just execute this code and you will see it's totally unpredictable. Okay. If anyone has any questions which you cannot ask vocally, please post in the chat. I'll just check in. So this is the okay. So the question all that it was asking is like, I mean, is there any predictability for the output? Which clearly no. You still have the main thread and the example thread, right? That can get executed in any order, and that actually results in any of these functions. Which of the following statements are true about threads? The thread is a part of a program, which we have seen, like I told you, like the process in Excel can have multiple threads, right? So it's a small part of a a single unit of execution, which is a part of some process. And a process is nothing but a program in execution, right, which is in the main memory. A thread is a lightweight process. So what do you mean by lightweight process? A lightweight process is something uh, which has, so say for instance, you take a full process. Okay, a full process has its own activation records, right? Has its own heap. So every time you want to switch from one process to another, in the case of multiprocessing, you have to save not just the state of the stack variables, but also the state of the heap variables also, right? You want to have a context switch between processes. As the case of thread, because the heap is all shared, all it needs is to switch between the threads just by saving the state in the activation records, right? That's why it's called a lightweight. The overhead involved in switching between two processes and between, if you compare it that between two threads, right? That the one that happens between two threads is much smaller than that happens for two processes. And so we say it's a very lightweight process. Because I mean, of course, the memory documents will be less because processes are much larger one. Right? We can create any number of threads in the program. We don't have any limitations except something that could result in a stack overflow because of stack overflow, memory overflow. The dependency is only about the system level resource that we have, either the CPU execution time or the memory level limitations that we have. Beyond program wise or program Java restrictions, there are no restrictions on the number of threads can be created. So how do we create user-defined threads in Java? So we said that okay, two ways to do that. You either implement the interface runnable or you extend the thread. So in both cases, there are different, I mean, you might wonder which one to choose, right? So in general, if you want to extend from some parent class for some reason, at the same time, you want to have this, say for instance, you have class employee, right? And you want to have a manager class, which has to say two manager threads have to run. So you will have manager instance employee and implements runnable, right? So here you cannot have extends thread because you can only extend one at a time, right? So if you want to have a manager object which is a runnable, then you have to use it. So it extends an employee and implements a runnable at the same time. So in general, I mean, I'm not very sure why, but in general, it is preferred that you go for an implements runnable than an extends. And then inside the thread, you pass this runnable object. The constructor of the thread, right, passes runnable object. Just like we have seen in this example, right? This is a runnable object, and you pass this runnable object as parameter to the thread constructor. Here it is. Okay. Now, this example, so in the first sight, might look like there is no error at all, but in fact, there is a compilation error, and that is because the thread.sleep method, right? This is actually this actually generates a checked exception. So that actually you will know only from experience. There is no way to differentiate, and in fact, the choice why certain exceptions have been made as checked and certain have been made unchecked is clear. There is no clear delineation. These choices have been made at the time when Java was developed. At that point, whatever was the the available or whatever was the requirements at that time, this was so. At some point, probably the developers of Java actually wanted to ensure that okay, you are going for threading, you're going for something which is some interruption somewhere. Are you sure that it is not going to generate an exception, right? So if you're sure, you want to ensure it. So I'm not sure, and I try to read it, but I'm also still not sure why this is a checked exception. So if you come across something like that, please do give us pointers in the discourse. So this you have to either put it in the you put it in the try-catch mode, and the exception that it is interrupted exception. generates what is known as an interrupted exception. Okay. So you put this one inside. So here you have not passed anything to this thread name, right? You are not passing any string here. So the t1.getName will by default assign thread the 0. If you create one more thread, it will give you thread 1. So this is also some priority for threads. Okay. So by default, the threads. Okay. So the priority of threads means that it can be from 0 to 10, any value from 0 to 1. This is the increasing priority. So if a thread has priority 10, then it has the highest priority. So by default, if you do not assign any priority to a thread, the normal priority or the default priority is 5. Now, what does this priority mean? Priority means that if there are say three threads, each with priority say 3, 6, and 9, then the one if we give a start, if we invoke the start method, the thread with the priority 9 will be given the highest priority. Or the JVM, as we just mentioned, right? The JVM takes some internal call on which one has to be scheduled. But that said, there is no assurance that this priority will be followed in all cases. It is quite possible that a low priority thread is scheduled first because of some other internal configuration. This is only like set priority and get priority are like, okay, you can set it to some point, it might do it, but this does not ensure that every time the thread will be executed based on this priority. You yourself can write a code and try to execute it and see. You will realize that the priority is probably, I mean, to some extent it works, but most of the time it's. So here, yeah. So get priority, because we have not set any priority to the thread. By default, the thread has a priority, which is 5. And the name of the thread is 0 because we have not given any name for the thread as a parameter. Okay, so here is an interesting question. So we have a class test and you instantiated a thread. But okay, what does this print? Does it print anything, or does it print thread running, or does it not print anything, right? So does anyone want to answer this question? Can you at least let me know that you are unable to answer?
Here.
Yeah. Sorry, you didn't say anything, Srinivasan, right?
I said I'm here, but I'm looking at the full question on the portal because the full question is not here, right? So
no, this is the full question. This is the last statement of this question. You want to try? Yeah. Just look at the full question. Because I have been speaking monotonously, right? So I'm just hoping at least one of you can give some input so that it becomes interesting. So do you want to try it, Srinivasan?
and the program is there, but what is the actual question? I'm just trying to look at the portal.
Output. What is the output of this code? See, if I show you the options, right, I have already marked the answer there. That's why I don't want to scroll down. This is all there in the question. and we are asking for the output of this code.
I think you should say thread running, unless I'm mistaken.
No, yeah. So that is the thing here. This is actually your creating an object of thread class, not the object of test class, right? That's the catch here. See, if you create test T1 equal to
Oh, it will throw an error. Okay.
No, it doesn't throw an error. It doesn't print anything. That's it. Because when you say T1.start is invoking the run method inside the thread class, not this run method.
Okay. Thank you. Got it.
Okay, because yeah, the test, this object is not of the test class, but it is of the thread class. And so it doesn't print it. Okay. That is the catch here. Yeah, so basically there is a user-defined thread. That's it. User-defined thread is if we have created a user-defined thread class and we have to instantiate it, right? So that's this. Yeah. Has anyone else or maybe does anybody want to attempt this question? Okay. So here what happens is, so the thread has various states. You have something called new state, and called runnable state, waiting. What about 7 or 8 stages?
The second T1.start should fail, right? Because by the time T1 would have been invalid state.
Yeah, T1 is already running state, right? This runnable state. This actually started and it's running. So you cannot start a thread which is already running, right? So when you say T1 equal to new test, then this is a new thread. When you say T1.start, it is in this runnable state, and whichever is the runnable state, you cannot actually T1.start, you cannot give it in. So it actually results to what is known as an illegal state exception. Oh. Yeah, correct. Okay. So it actually, yeah, it prints once because of this T1.start, but by the time it comes here, it generates an illegal state exception. Illegal thread state exception. Okay. So it prints thread and then it abnormally, it terminates abnormally. Abnormally means by generating an illegal thread state exception. So once it is in the runnable state, you cannot invoke the start method again for the same thread. It generates an illegal thread state exception. So I think this question we have removed. This is a slightly confusing question. So yeah. So this question again, it starts off from the main thread and you're instantiating this test class. You have an object T1. You're in the T1 start. Now here you are checking which is the current thread and you are checking whether it is alive. So the alive state is when the thread is in the executing state, right? So the thread is very much in execution, so it is alive. Then it sleeps for 1000 milliseconds, it is 1 second. And then it comes back, becomes active, and it is again alive. So in both states, it is actually alive, and so it prints true. So if you want to see it false, you can actually come out here after the start is over, sleep for another 1000 seconds. By then, this thread would hopefully have stopped execution, and then you print the T1.is alive. You will find that this thread is not active. So you can see the false there. So just to differentiate between when it is alive and when it is not alive, right? You can come here, sleep this main thread for 1000 milliseconds. By then, this run would have finished execution, and then you can try the is alive again. That will give you a true and false. So that is the. So this I've already explained. The priority actually minimum priority is Z1. That's okay. That was my mistake, I guess. Okay. So the priority of threads is from 1 to 10 and not 0 to 10. That was my mistake. I'm sorry. And the normal priority is 5. That's all what we get this question. Yeah. So here actually are creating 3 new threads. So we know that by default starts off with thread 0, thread 1, and thread 2. Right? But the interesting thing here is you don't know which thread will get executed first. Even though we start T1, by the time it reaches here, T2 may have finished this and this. So T2 might print first and then it could go to T3. So the interleaved execution between these three will mean that we cannot predict the order of these three statements which is being printed. So it's not possible to predict the order. So any of these options are possible. It's not possible to predict just because of this interleave. So here again, you have a main method, and instead of, before directly going to the T1.start, you're setting the priority of this. So we're asking what is the mistake in this. I've already mentioned that the priority is from 10 to 1 to 10. So 50 is actually an invalid priority. Okay. So this will actually generate a compilation error. The statement will not get executed. But even if this was something like priority 4, we cannot still ensure that this will be printed in the order, say thread. This is T1 is thread 1, right? This is T1, T2, sorry, T0, T1, T2. So ideally, when you say T1 has priority 10 and T2 has priority 4, T3, so you would have expected it to print like T0, T1, T2, but it may not be the case because I already mentioned set priority is only something like, we are suggesting that it happen, but it may not always happen. This program terminates due to illegal argument exception because this value 50 is not a valid argument with the set priority method. So this is a scenario where you are booking online the movie tickets, right? And you just have one seat left, which is like this is the only available seat which is left, and two people are trying to book the ticket. So you have just one movie ticket, right? You just have one movie ticket, and two people are trying. So this is how you name the thread. This first thread is for John, and second thread is for John. And when both of them start execution, so what happens is you go to the run function, and both of them, Job will be here, John will be here. So in any order, it can be executed. So eventually what happens is this available equal to available minus wanted. So this can actually be, this ticket booked for name. This is what we are assuming as the ticket booking step, right? So here it could either be Job or John or both of them. For both of them, it might print this because you are doing the wanted less than equal to available, and then you are doing this available minus wanted after such a gap. Even otherwise, interleaving we cannot predict, but we are waiting for a 1 second gap, and then you are reducing the available. So the next time someone comes, John comes and text, the available would still be 1, and so for both of them, this could be printed as good. Or it is possible that Job first gets and this statement is executed. Only by then John comes here, and then that case it is allocated only to John, or the other order is also possible. So the final output possible for this is that either one of them or both make it both tickets. And again, it is nothing but the unpredictability of the order of threads. That's all what's coming from this question. Okay. Which of the following methods belong to class thread? So wait and notify. I already told you this belongs to the object class, not the thread class. So this is one question which we have removed. So this question also we have removed because of some confusion. So why should test and set be atomic? So this is something we discussed in the last live session. To ensure that the thread that tests is not the same as the thread that sets, that's not correct. We want to ensure that both are the same thread, right? Otherwise, it doesn't make sense. The testing as well as the setting has to be done on the same thread, right? To ensure that there is a change in context in between the test and set operations, this is just the opposite. We should ensure there is no change in context. In fact, both of them should get executed as if it's a single operation, right? So there is no change of context there. To ensure that two threads do not start the test and set together on a variable. This is also not correct. Ensure the test and set of variable happens with no external interface. So this happens as whatever is a test and set has to happen as a single operation without any external interference, or rather no other thread trying to execute the if statement, or sorry, the test statement while the set is happening. Okay. So here is the main method. We're creating an object of T2. T2.start is there. And we are printing T2.c. So here it is basically just trying out, what are the possible options of, what are the possible values of C that can be printed here. Again, depends on the ordering in which the run and the main method get interleaved. So you're checking what are the possible outputs. So for instance, let us look at this for loop. So there n can be n equal to 0. So at that point, what is the value of C? C becomes A plus B, which is A equal to 1, B equal to, now n equal to 1, C is 3. So C is already 0, right? Immediately after this, before even thread starts, if the T2.c gets printed, then you will have the 0 value getting, the 0 getting printed here, right? The 0 will be printed. Now you have a value C getting 3 because C equal to A plus B, right? And A equal to 1, B equal to 2. So C gets 3 here. A is assigned B, which is 2 from here. This value, right? Now B is assigned the value of C, which is, now the next step, n equal to 2, C will get again A plus B, which is 5. So C is never getting the value 4. Now the value of C is only going to increase, right? So this value is not happening, 4 is not happening. Now A is assigned. So you can just do a simple handle and you will say see that you will get 8 also. After 8, you will not get 12. I don't, yeah, it's something bigger than 12. Okay. So just do a handle of this for loop. At any point, whatever are this value C can get, right? Those are the possible values that T2.c can print, because after this step, immediately the control might have gone to here and T2.c would have been printed. That's all the logic of this question. So yeah, I kind of missed mentioning the signal and exit. So when I was talking about the monitors, there are multiple ways in which the monitors can notify the other threads and exit. So when I said wait and then you calling the notify method, right? So one way to do that is you signal the other methods and you exit. When you are exiting, what you are actually doing it is you are coming out of it and coming into the external queue, which I mentioned about, right? And then you are actually waiting for your turn. So that is one way to do that. You're signaling the other threads that, okay, I have done it and I am leaving. The other method to do is signal and wait. You signal it and then you wait for your turn inside the internal queue. Okay. Signal and continue is when you are actually signal and wait is a notifying process passwords and goes in the internal queue of the monitor. So this is the signal and wait. Signal and continue is you finish this, you wake up the other threads which are waiting, but you continue with the execution of other steps in the code. In your whatever method you are executing, you continue with the steps, and the other method can execute only after you finish execution. You have asked the other threads to be ready, but you will still continue execution and the other thread can start only after you have finished the execution. So that is a signal and continue. And in Java uses the signal and continue. So now if you look at the options, so signal and exit is notifying process immediately and exiting the monitor. Signal and wait is notifying and goes into the internal queue of the monitor. Signal and continue is notifying process keeps control till it completes. And then one of the notified processes steps in. Yeah, so it keeps control and keeps executing the statements until it finishes all the steps in it, and then the notified process will take over the control. Notify must be the last instruction. This is the case of signal and exit because it is going to So in the case of signal and exit, it cannot execute any of these steps, right? So notify has to be necessarily the last step. So, yeah, okay. Which of the following is correct about monitors? It provides synchronization control the data being protected. We've already discussed this. The thread uses the method wait to suspend itself and give up the monitor. It uses a notify method, right? Notify method means that okay, I am done. Someone else can take it. It's not the. It ensures there is no deadlock, but it cannot ensure mutual exclusion. No, it ensures mutual exclusion by the programming console. That is the synchronized keyword, all that, right? It uses condition variables to control multiple internal queues. So my understanding is Java does not have multiple internal queues. Oh, yeah, okay. This is monitors in general, right? Okay, this is not Java. This is in general. So yes, it uses condition variables to internal. So as I told you, in the account transfer case, right? The account transferring from one to another. So I said that if account one transfers to account two, then account two can transfer the money to account one, right? Sorry, account three. So it has to wait. So account two, it will wait. Why? Account one is not transferred. One not transferred to account two. It will keep waiting, right? So this is the conditional variable. It's either an if statement or in general it is a while statement. It keeps waiting. It enters the waiting state until this condition is satisfied. That is what it uses conditional variables. Account one not transferred to control multiple internal queues. So this is actually entering. So the account two, the queue for the account two is the object for the account two is actually entering the internal queue and waiting, right? So it is waiting for the account one to transfer to account two. So it uses the. So this is the conditional variable. This is the conditional variable. That's about the EQ. I'll just look at the EQ questions also. So, okay. So two passengers, P1 and P2, are trying to book sleeper class tickets on the same train. Suppose there is exactly one sleeper ticket left on the train, but there is no provision to book RAC or waiting list. Consider Java code modeling the given scenario. Answer questions 1 and 2. So as you can see in this code, what is happening is you have a class passenger, which is implementing the run-w interface. So clearly it has a run method. Okay. Then there is a print method in which it is printing the coach number and the seat number. So what this passenger class does is it is actually in the run method. So if for say passenger P1, if you are invoking the run method, this means that it is booking the ticket for this passenger. Coach number 10, seat number 52 is the free seat that is booking and it's set in the status to book. And if you are asking to get the seat and PNR number, it will return these values. Then you have the getting. Now let us see what is happening in the main program. You have say passenger P1 here and passenger P2. Both of them are trying to book this one available ticket. Okay. Two threads are created. Now says if P1 dot booked equal to false, P2 dot booked equal to false, then P1 dot start. So first when the execution begins, this is the situation, right? Both are initialized as false. Because you have created, this is initialized to false. Okay? Here, as you can see, this boolean variable is initialized to false. So for both P1 dot book and P2 dot book, these are false. So P1 is initialized. Again, what we are hoping is that by the time it checks this condition, if either P1 is booked or P2 is booked, whichever comes here. So P1 corresponds to, sorry, the P1 corresponds to passenger P1 and P2 corresponds to passenger P2, right? So by the time it reaches here, if P1 is still not booked, right? If P1 is still not booked and P2 is also not booked, I mean that condition I don't think will work, but yeah. So what we are saying is, okay, you start from T2 dot start. Assuming that, I mean, ideally there was no threading or anything, right? There was no threading. If this was just P1 dot run, then clearly this will book first and this will be, then this Boolean variable would have become false and it does not go to the T2 dot start. But what happens with the threading is that once the T1 dot start is initialized, right, it goes to this step. It has allocates coach number equal to 10. By the time it checks here, the booked is still false because booked is set to true only in the last step of this, right? So when it checks for P1 dot booked, it is still false. And P2 dot booked is also false. So it initializes the P2 dot start also. So P2 dot start starts. So this is T1, this is T2. Now system dot out dot println P1 dot get name, P1 dot set and PNR, P2 dot get name, P2 dot set and PNR. You're trying to check which of them got the set. What are the possible scenarios is what we are looking at, right? So if T1 is allocated the 10, seat number 10 and 52, then we find that okay, T1 will print it as T1 and 52, and then only after T2 is initializing, then we find this is not even going to go there because okay, I will tell you. T1 starts, T1 goes here, and booked is also set to true. And if it's only after that the main thread reaches this step, the main thread is reaching the step only after the booked is set to true, then it does not even go to T2 dot start. So for the P2, the passenger 2, the seat number and coach number which we are trying to print here will still be 0, 0. Okay? Now what happens if both of them happen simultaneously? So T1 is here, T2 is here. T1 is here, T2 is here. T1 is here, T2 is here. By then, first step itself, it has gone. T2 has started execution from here. Both these variables are still false. So T2 is initialized. And then there is no going checking whether this variable has become false, right? So both of them will get 1052, 1052. So this is a practical scenario, right? If you do not have synchronization, there is only one seat which is left. Both passengers can end up booking the same ticket, which is clearly not correct. So this is one practical scenario that such a thing can happen. So the question, okay, let us come to the question. Identify the critical section in this code. So what is a critical section in the code? Critical section in this, in any code, especially in this multi-threading scenario, the critical section is the portion of that code which can lead to data inconsistency and which can lead to a race condition, right? So here, allocation of these variables is what is actually leading to the race condition, and hence we can say that the lines 9 to 11 are causing the race condition. You can see that 26 to 31, 32 to 33, they are not updating anything, so they are not causing any race condition. Which of the following is all not possible outcomes of the execution of the given code? So this one I have already, my goodness. Okay, got it. Yeah. So yeah, so this is P1 00, P2 10 52. So when is this the first? So the question is which of these are not possible outcome, right? So let us 0 0 10 52. Okay? When is this possible? So the answer is second question, right? So we have to see when this is possible, 0 0 and 10 52. So T1 has started, right? Let me just erase everything. Sorry. So when is the situation in which we get 0 0 and 10 52, right? So T1 has started. T1 is here, right? Okay. T1 has just gone to control is here. Now T1 is not executing. For some reason T1 is not executing. This is P1 dot book is 1, this is false. T2 dot start executes. T2 comes here, T2 comes here, T2 comes here. So why is T1 not executing? Depend on the Java, right? JVM which will schedule the lines. So why doesn't schedule? For some internal reason, we don't know. But this is a possibility. Right? So what happens with 0, 0 here? If you look at the P1 is still at this step only. It has not executed any of these steps inside the code. It has just been transferred control. It has just gotten control to its run statement, but it is not executed for some reason. By then T2 has executed the full thing. And now when it comes here, right? So this step P2 dot book equal to becomes T2 dot start has come, and it comes to this step, right? At this step, P1 dot get name is actually P1 only, right? But P1 dot get seat and PNR, if you see, right? Get seat and PNR is coach number and seat number. At this point, this is the whatever has been initialized as the instance variable, the default values, that will be printed for P1, which is 0, 0. For P2, because it has executed this step, this step, this step, this step, it will be allocated as same. So even though T1 dot start is what has been initialized first, it might still not execute anything. Before that, T2 can just execute all these lines and it can result in this step. So option 1 is a possible option. I come to why second is not a possible option. The third one is P1 equal to P1 and P2 both are 10 and 52, which I have already explained. The situation where P1 is here, P2 is here. P1 is here, P2 is here, P1 is here, P2. Both of them get allocated. And when it comes system.out.println, when you check it, both of them have been allocated in 10, 10 and 10, 52, 10, 52. So that is also one option. Then P1 is 10, 0 and P2 is 10, 52. So when does this happen, right? So P1 is 10, 0, P2 is 10, 52. When is this happening? So T1 is here, T2 here, T2 here, T2 here. Now main thread is executing this one. What happens? Coach number is allocated. Here it goes and checks. Coach number is allocated 10, but seat number is still 0. So the order of execution will be T1 is at line 9, T2 at line 9, T2 line 10, T2 line 11. Now you have main thread which is executing line 32. Now what happens? Only T1 has been allocated only the coach number without the seat number. So you get a 10-0 here, 10-0 here. Whereas T2 has executed all these steps, and so you get 10-52. Because the main is already printed. We are seeing what is being printed. No? So system.out.println main has executed this before even T1 reached the seat number. Right? So then what happens is you get the value P1 is 10-0, P2 is 10-52. So this is also a possible option. Now why is second one not option? Not possible. Only thing you can see here is P1 and P2, the order is interchanged. P2 is printed first, P1 is printed next, which is not possible because within the main program, a sequential execution happens and hence P1 is always printed first, followed by P2. So within the main thread, the execution happens in a sequential manner and therefore P1 is executed before the P2. So we cannot have the P2 being printed before P1. And hence this is the only not possible option among the given options. So if you have the practice assignment solution document, it is actually given clearly here. So just go. So I don't know how many of you have seen that mutual exclusion algorithms, if we saw it using the turn and request and request. So they're using two variables, two Boolean variables. So here also we are using something similar here. But the difference from that here is we are actually assuming some initial value for the Boolean variables. So the question is, you have an expression class which is implemented and it has a few variables here. And expression 1 extends this, expression 2 extends, and both of these expressions are evaluating two different things. Something is equal to sorry, A equal to 3 into B by 2. This is what it is. And then A equal to A into B. This is what is the first expression. Okay. The first one is, this is A equal to 4 into B by 2. I'm just reading from here only. I hope you can see this. And A equal to A into B. So these are two steps. So just by looking at the interleaving, right? So here there are so many possible interleavings, right? So this can execute first, this can execute first. Okay, so let me just look at the main, then you will understand better. So expression 1 is an object of expression 1 class. Expression 2 is an object of expression 2 class. Thread 1 is on expression 1. Thread 2 is on expression 2. So T1 dot start and T2 dot start. So T1 is actually accessing the method inside, run method inside the expression 1. T2 is inside the. So how does it synchronize? Any idea? Like, I mean, why is it that this A and this A are the same? Oh, okay. I'm not sure if I can get any response. Anyway, just keep myself. So, see, all along that we have been seeing, we have been looking at a single run method, right? The thread was on the same object, but two different threads on possibly the same object, right? But here, as you can see, these are two different classes themselves, two different objects, right? So how is it, why should there be an overlap at all? Why should there be an inconsistency at all? It's because these both have extended from the expression class, and these variables A and B are static inside this. So these variables A and B are for the class and not for the objects expression 1 or expression 2. This is for the class. So whatever update you do here, that will reflect in this class because these are static variables. So that please keep that in mind, otherwise you will not be able to understand why this variable is okay. So you actually look at variable possible combinations of these. But the interesting thing here is that we've already initialized the ready one with false and ready to with true. So once the T1 dot start is executed, T1 dot start is here, it goes here, it checks whether expression 2 is expression dot ready is correct. Then it will enter this infinite, sorry, the wait. This is a wait. I don't know if you can see that. This is just two open and closed flowery braces, which means that while this condition is true, it keeps waiting. So if this is true, that is, this is true, it keeps waiting. So even though we have started T1 dot first, it cannot proceed further because it is checking for this boolean which has been initialized to true. Now T2 dot start comes. T2 dot start comes if the run method comes, and it's checking whether expression dot ready one is true. It is not true because we have initialized it to false here. See? We have initialized it to false here, right? So what happens is, yeah, so what happens is, this is false, so this is directly going to execution of this. And here we are setting the ready to false. So by the time it checks this again, this is false and it enters this. So this is clearly a sequential execution only. Even though we have created thread and we have started both and there are shared variables and everything, because these Boolean variables have been set like this is a false and this is a true, there is a clear sequential execution. Hence, you have a definite output as compared to all possible outputs. These scenarios will come only if we had set both variables to true or both variables to false, whichever. Assuming the program terminates normally after a certain amount of time, which among the following is or are the possible values of expression dot A after the execution is completed, and that is 6 only because the variables, these Boolean variables are starting off with definite value, and that decides the order of execution of the threads. Okay? And that gives a definite output for the question. Okay, now we have question 2. Just give me a second. Yeah. So, okay. So you have a class that extends thread here. And the main program, we are instantiating two threads, one with value 10, the other with 20. The constructor, as you can see, initialize this initial value as 10. Now, you're starting thread T1. Starting thread T1. Right? So what does thread T1 have? Thread T1 has values 10, starting from 10. Right? So the init is set to 10 here. And starting from 10, you're incrementing 5 values. So you have to print 5 values. Right? So 10 to 15, not 5, 6 values. 10 to 15 you have to print using this one. And here, this one will print from 50 to 34. I'm not sure why we have written 35 here. I think it should have been 34. So T2 is actually starting from 20. Okay? So you have to start from 20 from here and 20 to 25 you have to print. Now the question is, choose the correct option regarding the code. It may print 10 to 15, 20 to 25, 30 to 35, and interleave none. These are the options. So what are the possible combinations in which this can be printed in an interleaved manner is the question. So let us see how the code works. You have, so first one is T1.start, right? T1.start, which will start from 10 to 11, 12, 13. Now T2, now then we have printing the 30 to 30, 31, 32, 33, 34, right? After that we have T2.start, which is T2.start, which is 20, 21, 22, 23, 24, and 25. So this is the main thread. The main is when this is done. So one interesting thing that you have to see is for loop is getting executed only after it completes execution that second thread is started. Okay. One interesting thing is the for loop is getting executed. This is going to be sequential because this is something which is happening within the main thread, and only after executing the for is when the T2.start is getting executed. So the thread actually it becomes a thread only after the start method is invoked, right? So until then, the 20 to 25 does not have any role and it does not print. But the moment it is 34, the largest value here is printed, the T2.start will start with the printing of 20 to 25. So how can what are the possible interleaving settings? So you have T1.start. So here T1.start will start by 10 to 15, right? Now some point this is started and then the main goes back to this one. Right? So 10, 11, 12, 13, 14, 15, this can get interleaved with 31, 32, 34, right? This can get interleaved in any manner because of this. The T1 is running here and main is running here. Right? So this interleaving can happen in any way. So 10 to 15 can be interleaved in any manner with 30 to 34. That is possible. Now compare it between 10 and 20. The 10 one starting from 10 and 1 starting. So once the 30 to 35 is over, the 20 starts, right? 20 starts. Now, if suppose 10 is printed, 11 is printed. Now the 30, 31, 32, 33 is printed. Then 13 is printed, then 34 is printed. Now the 30 is over. 15 is not printed. By then, the T2.start is invoked, so the 20 starts executing. Right? So the 20 might get printed, 21, 22, and then suddenly the 15 might get printed. So the 20s and the 10 to 15s also can get printed in an interleaved manner. Right? So 10 to 15s and 30 to 34 can get printed in an interleaved manner. The same way, 10 to 15 and 20 to 25 also can get printed in an interleaved manner. But The 20 can start only after the 34 is over because this is within the main program. This is a sequential execution. It cannot have an interleaved execution. Right? So this has to finish completely. The 30 to 34 has to print completely. Only after that the 20 will start. So the 10 to 15 can be interleaved with 30 to 34 or 20 to 25, but these two cannot be interleaved. So you have to pick the option which is satisfying this condition, which is the last one. It may print 10 to 15 and 30 to 35 in interleaved manner. It may print 10 to 15 and 20 to 25 in interleaved manner. However, 30 to 35, 20. So I have to check this 35. I think it should be 34 only. However, 30 to 35, 20 to 25 cannot be printed in real time, because I have already explained. 30 to 35 has to be printed first. You have to finish the printing of 30 to 34, and only then the 20 will start. So this semaphores question I need to check, so I will possibly look at it in the next session. I had some doubt in the middle, so I'll just check it and let you know. It's a slightly confusing question. So yes. So you have a last point, which is implementing the runnable interface. And you have the static method. So you can just note the static. Okay, so every time whatever objects are created a point, they will all see the updated value of x and y. It will not see a new value. It will see the updated value, which when the value of x and y are visible across all objects. The same value of x and y is visible across all objects of point one and point. Sorry, points. So all objects of points. You have a method update point. You get these parameters. You update. You display x and y. Now you're checking if name equals update. Okay. So how are you invoking the point method? Point method you're invoking using the string, which takes either the value update or display. Okay. So here you have said that okay, P1 is to be updated, P2 is to be displayed. We have T1, which is for the point P1, T2, which is for point P2. Starting T2 first and then T1. Now T2, when you start, what happens? T2 comes here, execution comes here, right? Because the start is eventually the run. Right? So if name dot equals update, is the name equal to update? No, it is display. So it comes here and it invokes a display method, which is this one. Right? Now T1 dot start, T1 comes here, again it checks for update. So this will be the update point. So it goes here and this will happen. Now the question is, which of the following are possible scenarios of execution? So what are the options? Update point of T1 after display of T2. Okay, so D. T1 has, only T1 has only update method, right? It will invoke only update method because we are checking whether the update, the string is update, here string is update, the string is update, and then we invoke only the update method. So the update point method of which one? The T1. That will come after display of T2. So if you see T2 has started first, but still because they can happen in interleaved manner, update point of T1 can happen after display of T2 also. Now display of T1 after update point of T2. Display of T1. So T1 does not invoke display method at all, right? So T1 is actually for the point P2. T1 is actually that of point P1, which has only update method. So invoke only update point. So this does not get invoked at all. So this is a wrong option. An update point of T1 after display of T1. Yeah. So okay, this T2. Yeah. T1 has only update, so it calls only update point. So T1 does not have the display method at all. So this is, I mean, does not, it has, of course, but it does not invoke this at all. Update point of T2 after same thing. So T2 does not have update point. T1 does not have display point. I mean, it has, but because we are checking the string and we are executing it, these two are not possible, and hence this is a only possible option. So you have a class bank which has a balance in 100, and you have an extract method which is nothing but a withdraw method, right? Withdrawing from the bank, and then you have name. This is, you can look at something like a ATM also. So you, this is the amount, and this is the customer who's going to withdraw. So if balance is greater than withdrawal, so if the ATM does not have such an amount, then so balance is greater than withdrawal, it means that it has sufficient balance for withdrawal, and it says that okay, this person has withdrawn so much money, it will update the balance. If it does not, then you can say that okay, you cannot withdraw so much money because the current balance is in this situation. And the withdrawal is a run method. So here actually the run method will invoke the extract method. Why we need this is because we want to have a scenario where the bank as such has, so it's not an ATM, so just forget about that example. So the bank as such has only a balance of say 100 rupees, and 3 customers are trying to withdraw say 20 rupees, 40 rupees, and 80 rupees respectively from the bank. And the bank, this is happening concurrently because each of them are not, they do not know about the existence of the withdrawal. I mean, they do not know that other customers are going to withdraw, right? So they will actually initiate the withdrawal for say 20 rupees, 40 rupees, and 80 rupees respectively from the bank. And this extract is actually a concurrent process. So if you come and check here, and we have started all the 3 threads this way. This clearly will cause a confusion because all of them will be allowed to withdraw. See here, all of them will be allowed to withdraw the amount, even though the total balance is only 100, right? This is actually shows they have withdrawn 140 rupees, even though the bank has only 100 balance, because the concurrency is happening without any synchronization. So any customer can withdraw any amount without worrying about the balance, which is not a correct thing to do, right? So in the next week, actually, we have an example where we show how the synchronized method will request to streamline this. So any order, see, I mean, it doesn't have to be that the order in which, so here sun, moon, earth is the order, but here we can have any order. So here you have earth first, sun first, the moon first, and moon. Here somewhere it says, okay, it cannot withdraw. And it depends on the interleaved order, right? You can look at all various possible options and see that all of these are possible outcomes of this program. Just look at the execution of this sequence method. So the T1 dot, so here when T1 comes, this extract method is coming, we come here, and at some point if this is here, T1 is here, T2 is here, T3. So different points at the T1, T2, T3 are, right? So T2 is here, T3 is based on different steps at which these codes are at the same point, will actually lead to all, I mean, it can actually result in all of these possible scenarios. Clearly, this is an inconsistent state because having only 100 rupees in the bank, 3 customers together have withdrawn 140 rupees, which is not correct. The given code, suppose you change the sequence T1 dot start, T2 dot start, T3 start, T1 dot run, T2 dot run, T3 dot run, then it is clearly a sequential execution. So what happens? 20 has been withdrawn, 40 has been withdrawn, then it will not allow the 80 to be withdrawn because it's actually 3 methods, right? So sun has withdrawn 20, moon has withdrawn 40, earth cannot withdraw 80 because current balance is only 40 because 60 has been withdrawn, so from 100 is only 40. So instead of start, so this does not achieve threading at all, right? This is just like sequential execution of 3 methods. So here threading happens and hence this inconsistency can result, whereas run, here it is actually executing as 3 sequential methods and hence this is the outcome. So the next week, we actually look at how next week, tomorrow, look at how these methods we can actually use the synchronized keyword here. Right? Synchronized keyword, which prevents multiple objects from accessing the same time and thus ensuring a consistent. Okay. So I have done the peak except for one question, which I will address tomorrow. Maybe I should have looked at it, but I was a little confused with the last one. So I don't know. Yeah. So that's it from my side. So does anyone have any questions or anybody wants to give any feedback on this two or any other questions related to any earlier content or anything you want to discuss?
Ma'am, can I ask a question about the programming exam? The online. Hello?
Yeah, sorry. Yeah, sorry, I didn't realize I was on mute. Yeah.
Oh, okay. So firstly, for me, exam quiz 2 was definitely better than quiz 1.
Okay.
Less tricky questions, I think. So,
okay. So you mean quiz 1 had trickier questions, is it?
Yes, because I was brand new to Java that time, 4 weeks into Java. So couldn't decide. This time I didn't see that kind of ambiguity in any question.
Okay.
So last time I think even the match the following, there were more options on the right side than the left side. So you had to think.
Right.
So quiz 2 was easier for me that way. I don't know if I got a better score or not. So my question is about the online programming exam. I was not able to because of the portal, and I really need to know how to make up for that.
Okay, so programming questions, there is no other way other than writing the code. So have you done all the practice and graded programming assignments on your own? Please just give me a minute. Let me just stop the live session. I mean the live streaming. Just give me a second.
Right, good idea.